Welcome back to Air Quality Matters. We already have the tools and knowledge we need to make a difference to the quality of the air we breathe in our built environment. The conversations we have and how we share what we know is the key to our success. I'm Simon Jones, and coming up, the first part of a special series of podcasts from India, where Air Quality Matters was the official podcast partner for the Healthy Buildings 2025 conference in Hyderabad. In parts 1 and 2, we'll be speaking with both the next generation of researchers from the region and industry. It's a fascinating window into what's at the forefront of science, what the next generation of scientists are focused on, and the problems they are looking to solve. But also from industry, the businesses on the ground, innovating, solving problems, and building the sector right now. Many of the challenges are the same. Many are different. What runs between them is a passion and drive to make a difference and share knowledge. I've been really looking forward to this. The Healthy Building Conference and ISIEC event was a really special one, and I hope these conversations can bring you a flavour of that dialogue. I say at the beginning of these episodes, it's the conversations we have and how we share what we know is the key to our success. And this extends globally. To truly understand how to solve the problems we have, we need to understand the full spectrum of the challenges and opportunities that face us. The perspectives on display here will feel familiar, but perhaps offer a fresh view. Don't forget to check out the sponsors in the show notes and at airqualitymatters.net. First up, we have the researchers. This is a conversation in order of appearance. Kumar Naduniri, Shruti Roberts, and Prativa Lamsal.
I really appreciate you taking time out of the conference because I know it's really valuable time down there. So I'm not going to keep you any longer than I have to. But it's a really good opportunity for us to hear from people coming into the industry that they've got some experience, how you found it and what you're seeing and why this stuff matters. So before we get into the meat of it, probably the best thing for us to do is just introduce ourselves to each other. So if we start with yourself, just explain who you are, where you live, and the kind of stuff that you're working on at the minute.
My name is Kumar Nadunuri. So I am from a city called Warangal, which is very near to the Hyderabad city. So I have done my graduation in this very same city, Hyderabad, and I have pursued my graduation on building services and technology. And then after I have worked for some time in the industry, and then I have pursued my master's in building science and technology in Bangalore city. And so after that, I started working as a research assistant in one of the private institute in Gujarat, where I found my research interest, and that is where my research interest in me, turned towards the PhD research. And now I am working as a PhD research scholar at the Indian Institute of Technology, Kharagpur, which is in West Bengal state. I am working on personalized ventilation and thermal comfort. So my interest is to make buildings more comfortable and sustainable and environmentally friendly.
Yeah, that's really interesting. And I know personalised ventilation is something that's talked about here quite a bit, isn't it? And really an up and coming subject. That's fascinating. Remind me to come back to that because we must talk about that. And yourself?
I'm Shruti Robert. I come from Kerala, which is located in the southern part of India. And basically, I'm a civil engineer. So I did my BTech in civil engineering from SEMS School of Engineering Technology, Karaguti, and it's affiliated in MG University, Kottayam. And after that, I did my master's, my MTech program in environmental engineering, again from SEMS itself, and it's affiliated to APJ Abdul Kalam University, Trivandrum. And after that, I had worked in 2 years for the research project, and it was in microplastics. It was in microplastics in the rivers. So it was in one of the urban stretch of a river, and also to the Vembanad Lake. It's one of the Ramsar sites. I worked there. So after that, I pursued my PhD. It is my PhD again. I'm doing it at SCMS. So it is affiliated again to APJ Abdul Kalam University itself. So the major thing was that I started with microplastics in river, and then it continued to another environment, air. So that is how I just started with my research project as such in air. So I deal with microplastics in air, and I'm focusing on indoor airborne microplastics.
That's really, I remember us talking beforehand. That was a subject I thought was really interesting that we've not really spoken about. You know, we're finding microplastics in the body. You know, the assumption has been through ingestion and through absorption, but it would appear that the air is now a real factor.
Yeah, we always talk about particulate matter, but I was very curious to know what is in that particulate matter in today, like in our modern lifestyle, especially when it comes to indoors. What is the composition of this particulate matter? We say it is dust, but according to the environments we go, the particulate matter composition can change. So in the residential environment, the composition of particulate matter will be different from that of an occupational building. And that exposure will also be varying because it's a very controlled environment, unlike outdoors where lot of dilution can happen. But in indoors, it's in our control. So and it is invisible to us. So if we don't identify it at an early stage, there are chances that there are a lot of health risk are there during their exposures.
That's really interesting. And that's another subject we definitely need to come back onto. So we'll hold there and let you introduce yourself.
I'm Pratibha Ramsal, an architect and also PhD scholar from Nepal. So my research mainly focuses on adaptive thermal comfort in office buildings. And basically wanted to have thermal comfort standard, which is basically focused to our own country. I think that's my area. So I'm also doing the visiting faculty member in the same university.
Yeah.
So that's drive me to do the PhD.
Yeah, really
that's
interesting.
That's the reason, yeah.
So we've got an architect, an engineer. You're an engineer as well?
Yes.
Engineer as well. So 2 engineers and an architect. That's like oil and water, isn't it? Do you lot get on, architects and engineers? On camera, yes, definitely. Yeah. So let's go back to some of these subjects then, because they're all really fascinating and also intertwined, particularly when we're talking about the indoor environment. Personalised comfort and personalised air quality, this kind of concept of bringing our indoor environment down to, we talk about environments having to feed the human level, but we tend to talk about that at a zonal level or at a floor or a building level. This is a real step forward, isn't it? This kind of personalised comfort. What's your kind of thoughts on that sector at the moment? Because it's been talked about a long time. There's been research about it for a while, but we're not seeing it manifest out there yet as a real solution in other than very particular circumstances. I know we do see it. What's your kind of thoughts on this sector and what you're seeing through your research?
So the research on personalized ventilation systems was started way back in 1990s, as far as my understanding from the literature studies. So initially there were so many studies focused on controlled chamber atmosphere based experimental studies, and then they started collecting the data from the field studies, like how the humans are adapting to the personalized ventilation when the personalized cool air is supplied at the face level and the underfloor level, how the occupant is actually adapting to that cool air. And if there are any issues like sick building syndrome effects, or if there is any uncomfortable conditions created by underfloor air distribution systems, or if the airflow is delivered at the face level, the eye irritations kind of issues also prevail. So in order to overcome them, what systems can perform better? So they started exploring on different kind of personalized ventilation systems, and they started coupling with a secondary background ventilation systems. And most of these studies were focused on indoor atmosphere based studies. And there were some studies computationally explored, and they tried to evaluate how the airflow is interacting with the room air and how the temperature profile and if there are any issues in case of airborne transmission effects, and how to reduce those infection control, and how better the personalized ventilation system can improve the inhaled air quality of the subjects. So there was the research on different domains of these subjects, but unfortunately there were very few studies from the field. And but in the early 2000s, so there are some universities like DTU, Denmark Technological University. So they have conducted the experiments and they started implementing in a field. In fact, there were a few studies. I recently had an interaction with one of the scientists from the DTU. So I had a conversation why it was not practically implemented in the field. And he said that at that particular of time, people were not very interested to, have this kind of personalized ventilation systems in their office, and they are not ready to invest more money. And eventually there was one manufacturer which it was not able to, manufacture so many devices. So because there was no such demand at that particular time of period, so this research was not up to the level as it should be. But recently, after the COVID incident happened, so people were realizing the importance of, indoor air quality and how to avoid airborne transmission issues. So which personalized ventilation has the ability to provide, high amount of fresh air close to the breathing zone, so that there is a high scope that the infectious issues can be reduced. So now there is an increased interest, but still there is a need for field studies. So I think there are many institutes from the USA to European countries, and then there are some institutes in South Asia, and recently 1 or 2 studies from India. So different parts of the world are trying to explore through the comfort chamber studies, simulation studies, and field studies. And I'm sure very soon they try to come up with the standardization, the implementation guidelines, and etc. So once these things are standardized, I believe these systems will be manufactured, and very soon the industry is going to adapt these systems. This I strongly believe.
Yeah, let's hope. And it always strikes me, and perhaps thermal comfort might be the key to unlocking this, because there's that saying that you can't please all of the people all of the time. And as engineers, the first thing that anybody complains about is being too hot, too cold, in a draft, not in a draft, too stuffy. So you'd think, wouldn't you, as a pitch, as an idea for people working in a space, that being able to sit at a desk and set the parameter to your preference, whatever that is, because we're all so different in our preferences, particularly with thermal comfort, that it would be a winner. And the COVID pandemic has made a big difference with people understanding the protective nature of these kind of systems. But you're right, it's that who's first to move and create the products that are going to be sold into the spaces. I think it will be a real challenge. What's your research kind of focused on at the moment? What part of this are you looking at? Thermal comfort part?
Yeah. So my research mainly focuses on providing individual thermal comfort preferences, while also ensuring the high indoor air quality, while also focusing on the energy savings part. So this kind of work involves 3 stages of work, and we are also unfortunately not able to focus on the more field studies, but we are into providing personal level thermal comfort and high indoor air quality, while also focusing on the energy saving studies. And to this point, I'm also interested in coupling the personalized ventilation system with one of the low energy cooling system. So I am trying to do the simulation studies. If we couple with liquid desiccant type of system with a personalized air conditioning system, we can provide the air quality and comfort in a much better way, because the liquid desiccant based system has no compressor kind of components, so which is very much low energy cooling system. And the India is kind of a tropical climate where the required heat energy can be generated through the solar energy in India.
So for the layman, in as plain English as you can,
right?
What is a desiccant based system? What's happening there? It's not evaporative cooling. Is it evaporative cooling through a desiccant. How does that work? What is it?
So the liquid desiccant based system is basically it is a system that absorbs the moisture, because the system uses the liquid based desiccant solution like lithium chloride, magnesium chloride, then potassium formate. So these kind of solutions have a high affinity to the water. So when the moist air passes through this liquid desiccant solution, so it will absorb the moisture content from the air. So the liquid desiccant system basically does absorb the moisture from the air, and then it treats the moisture, and then supplies the hot air. And that hot air, if we can couple with the indirect evaporative cooling, and we can reduce the air temperature without much using the electricity.
So by taking the moisture out of the air, you're able to reduce the energy component in cooling it in the first place. Got you. That makes complete sense. That's one to follow up on, I think, is liquid desiccant cooling. And as a funny aside, I thought I heard, and it resonated for me, one of the potentials for personalised ventilation has been the move to working from home. Globally, we've seen a lot of very high-end organisations with very high-end staff working from their offices for large parts of the time. And an employer has a responsibility for the comfort and air quality of an employee, no matter where they work. So there's an interesting opportunity for personalised ventilation to be delivered in a working from home environment, because as an employer then, you're just having to manage the space where your employee works, not their entire home. And that's always the challenge from working from home is it my job to heat a person's whole house or cool a person's whole house? Or can I just cool the desk that he works or she works in for the day? It's a fascinating area. And talking of fascinating areas, my ears picked up when I spoke to you the first time, because I'd only just been having a conversation about particulate matter and the fact, and in fact, one of the podcasts that came out this week from me talks about a landmark report in England about air quality and this understanding that the stuff that we breathe is moving across the tissues of the body and is multi-systemic, that there isn't a part of the human body, whether that's early onset dementia, Alzheimer's disease, cardiovascular disease, liver cancer, impacts on the endocrine system, you name it, the air that we're breathing is impacting our long-term health. But I haven't heard plastics as part of that conversation. And that makes complete sense. So you stumbled onto this. You were looking at plastics and microplastics in river and water environments.
Yeah.
What was the trigger for you for air quality? Was that a conversation that you had with somebody that said, have you thought about plastics in air? Or was this something that came up as a research thing? How did you move from water to air?
Yeah, so I started with the sediments in rivers. So I was focusing on near the landfill or the dump site. So obviously there were a lot of sediments, microplastics were there in the sediments. Later on, I moved on to the topsoil. So topsoil also have. So one by one, I investigated the environment. And interestingly, that time my research was just progressing and I was just entering to my PhD. So we have to set up this research proposal. So it was a very funny incident that I am quite an allergic person. So I'm having a dust allergy. So I just went to a shop where it was like a synthetic textiles shop. So it was not much of a big kind of shops. It was more like a wholesale shops. So when I just went there, I just told them to cut a particular kind of fabric. So it was like a go down kind of environment. And I just entered and they started to cut it and everyone else was sneezing there. So it was very interesting. It was very curious for me. Yes, obviously dust will be there, but a sudden thought was there, like only dust? That was a virtual question. So there will be particles, that synthetic particles, which also might enter through my respiratory system. So that was just a spark of my proposal. So later I just searched for my research, all this literature reviews, and I found that the study is really overlooked. Like there are a lot of studies in rivers and lakes and in even marine oceans. But when it comes to air, the studies are very less. So that is how I switched to the air environment. And unlike the other environments where at least we can control the movement or the dispersion of this pollutant, when it comes to air, we cannot actually control it. It is actually, the size is actually very less. Like when I did my field study for the sediments, maybe the size of microplastics would be actually microplastic, the size dimension is lesser than 5 mm. But the size might be like 1 mm or maybe let's say 500 micrometer to be the lowest size. But for the air, the minimum size starts from 200 micrometers and it goes down. And that was very much of a health risk when it comes to air because we cannot control that exposure. At least in water, we can just filter and we can just have that water. But when it comes to exposure from air, it is very much riskier. So that aspect of health and also that control, we cannot control that environment. So these factors was very curious for me.
Yeah, that's really interesting. So where are the boundaries of your work? As an engineer, are you looking at engineering controls and whether that risk is in the air and what are the effective mechanisms for protecting us as an engineer from that, like filtration or other mechanisms? Or are you starting to look at the evidence as well within your work of, can we tell if the presence of microplastics in the body is as a result of air quality? Where's your work start and stop? Is it at the measurement in the air phase and what we can do about it? Or are you looking at is it making its way into the body piece?
I started, like I've told before, I started from shops. I was very interested in doing for commercial shops. I'm not talking about the shops which is protected with lot of ventilation, etc. I'm talking about the shops like developing countries where the shops are not much ventilated. It might be like a go down. It's a wholesale factor where all these types, any kind of synthetic, I'm not talking about only plastic kinds of textiles, but any kind of plastic products that are stored in the indoor environment. So I selected a different kind of shops. So there was something like a toys shop, there was something decor items shop, and it was a Christmas season. So we do have lot of that kind of, even the Christmas tree that we find, it's definitely of plastic. So all this plastic, so I've selected some shops like that, and I just took the deposited dust from it, and I just investigated for the presence of microplastics just to know the characters, what we find there. So we find a wide range of sizes and a wide range of polymer types are found from there. So that is how I started my study. Later, now I'm in a phase where I wanted to know the pathways. When it comes to indoor airborne microplastics, when I talk about respirable microplastics, I want to know the pathways. Is it from just the indoor or there will be a contribution from the outdoor, but from indoor itself, what is the pathways? What are the emission sources that can be leading to the emission of or the generation of this respirable microplastics?
Yeah. And you wonder at a microplastic level whether that accelerates off-gassing as well as plastics break down. I imagine exactly. You must be seeing associated risks with that not just the particle itself, but what that particle is doing to the environment. Really fascinating. So this sounds to me like all really early stage stuff. Have you found many other people in your field looking at this area yet? Are there many of you?
Definitely. I do connect to people who are working in, but most people are working in microplastics in water, but we do have a connection with microplastic in air, but they focus on the outdoor microplastics mainly. Yeah. There are just studies, very less studies. They are focusing on indoor microplastics, but I'm particularly focusing on respirable indoor microplastics.
Yeah.
So that is my current stage of PhD. So I'm very curious to know what are the sources and the emission pathways.
Well, it sounds like it's definitely one to keep an eye on because it sounds like a fascinating area of research. And I can imagine, because my head's already playing this out. You've got does it exist? Is it in the environment? How much of it is in the environment? Can we do something about it in those environments? And we can all imagine the kind of workplaces that create some fairly troubling environments in that respect. But I'm also then thinking there's an awful lot of medical tie-in here required as well, trying to understand pathways and mechanisms on the human body. Because I think we're only really just starting to understand that from a medical perspective, the impact of microplastics in our bodies. So it sounds like that you've got work for the next few decades ahead of you anyway, by the sounds of it.
Yes, my boundary actually I've not kept for the health part because I consulted with scientists and Neary. So I consulted with the scientist. So he told that we need much of a health expertise to continue. So maybe for my postdoc, I'll pursue with that. But for currently, I'll only just focus on this emission pathways, just the sources and the emissions of this microplastic generations.
Really interesting. And I'm always fascinating, Prativa, architects in this space, because it's an interesting field, architecture, in that it's increasingly becoming a technical discipline. You know, the vision of an architect of old is a black polo net wearing artist, you know, scribbling beautiful buildings, right? We all know that kind of trope. But increasingly now you're getting really into the depths of building science and physics, but you come at it it's a different viewpoint, isn't it? I imagine it, and particularly I imagine from the adaptive comfort perspective, trying to understand how you make spaces work for people.
Yeah, exactly.
Yeah, really fascinating area. How do you describe what you do to people? So as an architect looking at adaptive comfort, particularly in workplaces, what are the kind of outcomes that you're looking to achieve through your work and your research and what you're doing?
As you just mentioned, that adaptive thermal comfort is more related to what people are doing to adapt their indoor environment, right? So my focus is basically towards the adaptation, how they are behaving in their environment to be comfortable inside the office building, right? So there are basically 3 types of adaptation. There is behavior, psychological, physiological, right? So I'm looking after only the behavior part, how they are behaving, that might be the clothing level, that I'm wearing this kind of clothes, and in summer people are wear only t-shirt like you are wearing, and winter people use jacket things, right? So I'm looking after that thing, behavior, that is one behavior. Another behavior might be people are opening the window. That is also behavior parts, right?
Yeah, so physically interacting with the space.
Interacting with the spaces, being cozy while sitting, those kind of things. One part is that. And another thing is basically in if you see in the worldwide, there are so many standards about the thermal comfort, adaptive thermal comfort model, right? If you see there is ASTRAE standard, the global standard is ASTRAE standard, SANI standard, it is from Europe, and IMAC there is from India. So what I believe is adaptive thermal comfort is based upon climate and context, and also culture, right? So it is the adaptation behavior is dependent upon, it is influenced by the climate, culture. So I wanted to see what is happening in our context, since there is no thermal comfort standards in our country. So I wanted to look upon that part. So how people are behaving in their indoor environment to be comfortable, and also what will be the model. In simple terms, they are giving in the model is if the outdoor temperature is increasing, our comfort temperature inside the building will also increase. That kind of model has been developed worldwide. So I wanted to say whether in our countries, what will be the model, and also looking after that behavior.
Yeah,
part.
That's really interesting. And from the architect's perspective, that's feeding into how you then create the spaces, the physical spaces that work for people in that regard. Can you provide environments that give people the agency to interact?
Exactly.
You know, that a lot of the challenges, particularly with thermal comfort, is the feeling that you can't control the space you're in.
Exactly.
You know, or that you haven't got areas where people that are more comfortable can be, and people that are cooler can be somewhere else. And I always love the image of there's a great picture in Paris taken at exactly the same temperature, one going into winter and one going out of winter. And going into winter, everybody's wearing coats.
Exactly.
Because they feel warm from the summer, and this feels like a really cool day. And then in exactly the same weather conditions, 6 months later, everybody's sat there in short sleeve shirts because they've adapted to a different temperature over time. Yeah, it's a fascinating space that when you add the human ingredient to it, it's really interesting. I think the next really interesting part to come on to is kind of a two-parter really, is the kind of how you got here and the where you think this is going piece, because I always think they're really fascinating to understand. Because you're coming from a younger generation, that's quite a condensed period of time. So maybe if I start with you, like, how did you find, what's been your kind of journey to doing the work you've done? Because you've done quite a lot. You know, you've been both in academia, then out in industry, then back into research again. Like, how did you find yourself at the beginning of that journey? What was the thing that kind of triggered, or is it just, you've just kind of found yourself falling into air quality?
When I have completed my bachelor's degree, then I immediately started working in industry. So where we are given certain tasks to do the work in office buildings. So basically what we are doing is some senior engineer will be designing the buildings in terms of HVAC systems or building services systems. And there will be one senior architect who will be coordinating with the services drawings and architectural drawings. So for every project, there is a similar pattern. And I believe that with every project, there are different design challenges and different ways to, showcase the talent and have innovative approaches. But what I have personally experienced that everybody is going through the same pattern of, designing, doing some calculations, coming up with a certain design criteria and then go with the architectural coordinations, and then they just keep on implementing it. So I kind of felt that entire process is very boring, and we are not actually putting our innovative approaches or whatever our ideas, whatever we think the solutions can be implemented in a different way. So we were not actually being, utilize those kind of skills there. So I thought I would try to pursue my, specialization studies on sustainability. And then I went on to do my master's in building science and technology, where I have studied the passive kind of cooling technologies, the natural ways to, cool the buildings and reduce the energy consumption of a building. So I have learned a basic fundamental knowledge on these things during the master's time. And then when I completed master's, I started working as a research assistant in one of the Indo-US joint project. So I'd like to thank my boss. So he has given me the good opportunity at the early stage of my career. So where I started overlooking the experimental studies, and I tried to kind of deal with the data analysis and try to look into the different variables, the variables that are playing a major role in providing comfort, and how the energy consumption can be reduced, and how the air velocities are playing a role in, increasing slightly more higher temperatures. So this is where I have got my spark of, getting into this side of research. So basically I have got my interest in thermal comfort and air quality research idea began from that point. And then after I have joined as a visiting faculty in Hyderabad for one semester. Then I had started teaching one or two subjects where I felt myself challenged. So we need to prepare, and then we have to teach to the students, where students will come up with a different kind of questions which I have not experienced before. So I think this is a little challenging to me. And then I started looking into the literature papers. I kind of started developing a research proposal at that point of time. And then I started applying. Then I joined in Indian Institute of Technology, Kharagpur. So where I was continuously developing the refined proposal. And then when I started looking into the literature papers, then I realized how important it is to, do more further research in the area of thermal comfort and indoor air quality. And there were so many incidents, like people who are uncomfortable. Like if we take an example in office buildings, people from the different climatic background and people from the different lifestyle come and work in a same office environment. So it is often like difficult to provide each person preferred comfort conditions. Then I started like diversing my literature study, and then I found the research on a kind of particular domain called personalized environmental control systems is been going on from more than 3 decades. And recently, kind of after the COVID incident, many people were started taking up these areas into their research career. And I feel there is a more need, and there is still more scope to explore in this area, while also to if we want to provide subjects individual comfort conditions, it is necessary to explore a kind of technologies to provide those conditions.
Do you know what strikes me about your journey is it's that classic engineer turned researcher journey that's doesn't like the look of the normal, and just keeps going deeper and deeper into the there's got to be a better way, there's got to be a better way, there's got to be a better way, you know. And the more you specialize,
right.
You've gone all the way from kind of mass production buildings and engineering to sustainable green buildings to thermal comfort's really important, personalized, you go down and down, up and down. Yeah, that's really fascinating. And of course teaching is another skill in and of itself, and nothing makes you know your subject better than having to teach others that subject. Yeah, no, really interesting. What about yourself? Like, how did you find yourself? Well, you said you started looking at plastics and sedimentary in waters and rivers and things. Because when we were talking earlier, we talked about a little bit about your transition from plastics in water to air quality. But I'm interested in how you kind of got there in the first place. What kind of brought you into that kind of environment engineering?
Okay. Firstly, I started in with rivers. So there are 3 sectors that I did in with rivers. It was water, it was sediments, and it was topsoil. And along with the rivers, I also have examined for fishes. So in fishes also, I used to find this microplastics, but in a very, very lesser size and also very lesser quantity. So that was another thought for me. If it can be a factor in fishes, then why not in humans? So that pathway was by ingestion. Like when we eat fish, definitely there was another controversial stuff was that we remove all those parts and gut part from the fish